Great. So good afternoon, everyone. So my name is Erik Unemyr. I'll be sharing some of the updates from the Asia Pacific side of the ROS-I Industrial Consortium today. So as Matt shared earlier, so we're based out of the Advanced Manufacturing Technology Center here in Singapore. Okay, so Matt, I'll take a note and I'll be happy to share a bit more information about interoperability and kind of IoT, edge device connectivity, robotics some other time here. Today, I wanted to talk a little bit more about some of the quality efforts that are ongoing in the community, but also how ROS-I Industrial contribute to part of that discussion as well. And then I'll of course share some regular updates on what's happening in the consortium here in terms of membership training activities and so on. So a quick membership update. So we have one new member joined us in the Asia Pacific Consortium very recently. It's a company called Cognicept Systems. So they provide human in the loop remote intervention solutions and services that are directly plugging into ROS-based products. So if you're interested in this type of technology, you have the link there. You're able to find a bit more information about what these guys do. Okay, training is similar to Matt's update here, is maybe an area where we had some challenges here the last few months in terms of the COVID situation down here in Singapore, but we're glad to announce two things. So I think the first thing is we're happy to announce a partnership that we're doing with our member Singapore Polytechnic. So we'll be starting to conduct courses together with Singapore Polytechnic in order to increase the frequency of our ROS industrial trainings going forward. The second part is we will also start with fully digital trainings. Our first training actually falls on the same week as Matt shared here, but of course in a different time zone. So the first training will be on the 20th of July. The registration is now open, so if you're interested in this, go ahead and register. This course will be suited for anyone basically operating from the Southeast Asia or the East Asia time zones, because covering all the way to China and Japan. We have a total of 4 courses that we are planning using the digital format for this year. Another subsequent training in August, one in October, and one in December as well. And we'll, of course, continue to monitor the situation here and look at when we are able to start conducting physical courses as well. Okay, so a couple of events updates. Some of you may be aware we had originally scheduled our annual Asia Pacific workshop for second quarter. We decided to hold off on this event, but we are now looking at getting this event organized in early Q4. We have not yet announced the official date and open up the registration, but we do expect to do that quite soon. So do look out for the APAC annual workshop on rosindustrial.org, as well as through our LinkedIn channels and our APAC newsletter. And we will be looking at means to also connect to this event digitally this year as well, which should be allowing also for more people to call in and dial in for those that don't have the opportunity to travel for this year. So the overall events calendar, it's quite a digital format for this year. So of course, the trainings that I just shared, we'll be conducting those digitally for the remainder of this year. We also will continue to do our community updates, both our global updates like the one that we have today, as well as regional developers meetings where we share a bit more technical content in those sessions. And by the later part of the year here, we have the upcoming workshop potentially a digital format for ROS-Con, and of course the European side of the consortium are looking at the European conference as well, typically by the end of the year. I assume maybe Christoph may have some updates on that event here later. So today I actually wanted to share a little bit more about some of the quality efforts that are ongoing in the community overall. I know a lot of organizations are very interested in quality, and especially when it comes to open source, because there's sometimes some contention and concern in terms of how you would adopt different types of open source packages and still maintain or ensure quality. So there's quite a lot of different activities ongoing here. I'll try to just summarize these and also provide some color on some of the additional things that the ROS Industrial Consortium potentially may contribute in this effort as well. There's an ongoing ROS enhancement proposal called REP 2004. This is a global community effort taking place at the moment that is looking at standardizing the SOPs or the quality process related to ROS packages. So this effort includes contributors from the industry community as well as ROS Industrial Consortium as well. You have a link there. You feel free to read more in depth about these activities. There's quite a lot of information there available. This rep is kind of reaching its finishing stages. But to give a really quick crash course, there are basically 5 standardized quality levels that will be defined. One being the highest, which will be very mature packages that have been proven. They are operating at high performance, high reliability, and also have kind of strict or maybe controlled maintenance efforts to ensure that those packages remain at high quality. 5 being more uncontrolled or more experimental packages that you probably may want to use at your own risk. So the way that the community will measure the quality of packages going forward will be adopting 7 key metrics. You have the 7 key metrics summarized there. So some of these metrics are more soft aspects and process-oriented aspects, such as your process control. Do you have active maintenance? Do you have multiple maintenance or an organization backing the maintenance of this package? Some of the metrics are more technology-oriented or technical, such as the actual testing, test case coverage, some of the dependencies, library dependencies, or platform support that the package may have. So for us, one of the focus areas that we're looking at is the testing area, metric number 4, because we do feel that automation testing is one of the key drivers for quality, but also for maintenance and sustenance over time. And once you dig into this, all of these 7 metrics are actually a lot of sub requirements here that you should be adhering to in order to obtain a certain quality level for your package overall. So for the testing side, it includes things like, which many of you may be familiar with, things like code coverage, different types of running through your code through different types of linting tools and static analysis tools and so on. And of course, you need to have some degree of system tests that actually cover the key functionality of the package that you provide. So when you look at how this also relates to some of the past efforts that the ROS Industrial Consortium has made and some of the ongoing activities, in the consortium we have the Industrial SIA package, which is a popular package to adopt continuous integration for your ROS package. It's primarily maintained by Fraunhofer IPA, Matthias Lüdke. And there's quite a bit of recent enhancements being made to this tool. So this tool now includes support for quite a few ROS-1 releases, but also all ROS-2 distributions. And there's quite a bit of choice as well in terms of what continuous integration tool you actually want to connect this to. So today it has support for both Bitbucket, GitLab, and Travis CI, for example, and GitHub Actions. There's some additional improvements that we're also looking at for industrial CI. So we currently have some pull requests out that will soon should be merged in, that include additional support for code coverage through codecov.io and coveralls.io, as well as default support for the Google sanitizers, the address sanitizers, and the thread sanitizers. So these two areas in particular actually tie back quite well to some of these subsections in REP 2004 for testing aspects as well. And so if you connect the dots for all of these, you would have your quality policy that's defined by REP 2004. Of course, within your own R&D and development or package, you probably have some type of R&D and sustenance process in place. You will likely have a certain degree of manual testing that you're conducting, and you might be hopefully are adopting the industrial CI package to also implement a certain degree of unit testing, automation testing, and adopting some of the automatic tools for enhancing the quality of your software. So these three key processes actually go into a self-declaration of the quality. So you have a new file that you would be delivering or launching together with your package, which is actually your quality declaration. And this quality declaration is answers all of the specific sub-requirements and those 7 key metrics that the REP 2004 quality policy state and declare. So this is all good, right? Except that one of the challenges that we do see as well is that the quality declaration is quite good if you do a new development. You go through your quality process, you declare, and you go through everything. But typically what happens is sometimes you have a challenge over time. Typically when packages lose maintenance, it might have been well maintained in the past, but eventually because of various reasons, an organization or a developer maybe stop maintaining it actively. You might actually have degradation over time. So one of the proposed additional capabilities that we might adopt for the industrial CI package would be to look at also standardizing the acceptance criteria on per level on the 5 tier levels of quality for the specific automated process flow that industrial CI supports. So for example, if you're doing code coverage, you might have a certain acceptance criteria on a certain process step to achieve level 1 or level 2 and so forth. The benefit of you as an adopter of the package, you would have better visibility on, and also as the developer, of course, as well. You would have better visibility on quality degrades over time, and you can actually see more clearly some of how the degradation of some of the process steps actually impacts your quality level of the package overall. And you would have instantaneous feedback, of course, because this is now a CI system. The second benefit for adopters of packages that follow this or follow and use the industrial CI package would be that you would have a higher degree of standardization and visibility, as you would now have also a specific level of quality. It can be defects per 1,000 lines of code or code coverage in a certain percentage. So you would actually now have more clear metrics on the specific quality, not just whether a quality tool is adopted as part of the quality process. So that's something that we're looking at. We'll be providing some specific recommendations for this and put up a proposal on how we could adopt this and provide some ease of use for both maintainers and end users adopting the packages to have better visibility on quality going forward. Okay, so that was probably the main sharing I'd like to do today. I just have a very small update on upcoming releases here. So we have a package that we'll be releasing in end of next month. It's a package relating to perception as well. So it's a perception toolkit. It will be a production-ready ROS-I package that is intended to allow you to very quickly adopt adopt, train, and deploy different state-of-the-art computer vision models for different types of industrial tasks, such as detection, classification, tracking, and eventually integration with different types of manipulation-related tasks as well. So this will be open source, of course. We'll be publishing it on GitHub. We'll share a bit more details about this once we release this package in July, and we'll be providing good tutorials and examples as well, so that users have good ability to adopt these packages. It's actually intended to be a very easy to use package for quickly getting a perception pipeline up for specific tasks. It will be using TensorRT for the deployment framework by default. So it will be supporting NVIDIA GPU acceleration for those that require that. It will also be supporting Open Neural Network Exchange or ONNX models, which means that there's also a higher degree of portability of the machine learning models that are generated, so they can actually be also deployed on other frameworks as well. So even though TensorRT might be the default framework, deployment framework for GPU acceleration, you actually have the choice of adopting other open source packages for this as well. For example, if you want to use a CPU only mode, if you do not have this specific set of hardware. So do look out for this. We'll be sharing a bit more information about this, and also some use cases, some sample environments and tutorials as well going forward. So that's all I wanted to share today. Happy to take any questions. Else I'll leave it over to Christoph here to share more updates from the European side.